Hello again and welcome to another training module from CloudMasters Inc. In this module, we would be exploring infrastructure as code, a new era of cloud management. The cloud has revolutionized how we build and deploy applications, offering unprecedented scalability, flexibility, and cost-effectiveness. Managing this dynamic infrastructure, however, presents new challenges. Traditional manual processes are slow, error-prone, and struggle to keep pace with the rapid evolution of cloud environments. Enter Infrastructure as Code, or IAC, a transformative approach that empowers you to manage and provision your infrastructure through code, just like you manage your application code. IAC brings the principles of software development to infrastructure management. This includes version control, automated testing, and continuous integration and continuous delivery. By defining your infrastructure in code, you gain repeatability, consistency, and auditability. This eliminates manual configuration, reduces human error, and accelerates the deployment process. Imagine deploying complex multi-tier applications with a single click, confident that your infrastructure will be provisioned precisely as intended every time. The power of CloudFormation Sculpting your AWS infrastructure. AWS CloudFormation is a cornerstone service for IAC within the AWS ecosystem. It allows you to describe your desired infrastructure in a template, which CloudFormation then uses to provision and manage the resources automatically. These templates, written in JSON or YAML, define the resources you need, their configurations, and their dependencies. This declarative approach simplifies infrastructure management by abstracting away the complexities of individual AWS services. CloudFormation offers a range of benefits. Firstly, it promotes consistency and repeatability. By defining your infrastructure in a template, you ensure that it is deployed identically across different environments, reducing the risk of configuration drift. Secondly, it enhances collaboration. Templates can be shared and reviewed within teams, facilitating knowledge sharing and best practice adoption. Thirdly, it streamlines the deployment process. You can deploy and update your entire infrastructure with a single command, significantly reducing deployment time and effort.
GitLab, the collaborative code hub for infrastructure and beyond. GitLab is more than just a Git repository manager. It's a complete DevOps platform that provides a centralized hub for managing your entire software development lifecycle, including your infrastructure code. GitLab integrates seamlessly with Git, the distributed version control system, allowing you to track changes to your infrastructure code, collaborate with your team, and revert to previous versions if needed. GitLab's core strength lies in its collaborative features. Merge requests enable team members to review and discuss proposed changes before they are merged into the main codebase. Issue tracking allows you to manage bugs, feature requests, and other tasks related to your infrastructure code. Built-in CI/CD pipelines automate the testing and deployment of your infrastructure, ensuring rapid and reliable deployment.
Unveiling the essence of AWS CloudFormation. AWS CloudFormation stands as a pivotal service within the AWS ecosystem, empowering you to define and manage your infrastructure as code. Imagine constructing your infrastructure with the same precision and control as crafting your application code. CloudFormation enables you to model your desired infrastructure in a declarative format, specifying the resources, configurations, and dependencies in a template. This template serves as the blueprint for your infrastructure, enabling automated provisioning and management. With CloudFormation, you gain the ability to orchestrate the creation, modification, and deletion of a collection of related AWS resources, known as a stack. This simplifies infrastructure management by providing a unified view of your resources and their relationships. CloudFormation handles the underlying complexities of individual AWS services, allowing you to focus on the desired state of your infrastructure rather than the intricate steps required to achieve it. CloudFormation's declarative nature eliminates the need for manual configuration, reducing human error and ensuring consistency across deployments. You define the desired end state of your infrastructure, and CloudFormation takes care of the rest. Section 2. Mastering CloudFormation templates. Your infrastructure blueprint. CloudFormation templates are the foundation of infrastructure as code with CloudFormation. These templates, written in JSON or YAML, serve as the blueprint for your infrastructure, defining the resources, configurations, and dependencies. A well-structured template is essential for ensuring the successful deployment and management of your AWS resources. A CloudFormation template comprises several key sections, each playing a vital role in defining your infrastructure. The section is the heart of the template, where you specify the AWS resources you want to create, such as EC2 instances, S3 buckets, or RDS databases. Each resource declaration includes properties that define the resource's configuration, such as instance type, storage size, or database engine. The section allows you to customize your template by defining input values that can be provided during stack creation. This enables you to reuse the same template across different environments, such as development, staging, and production, by simply changing the parameter values. Parameters promote flexibility and reduce the need for creating multiple templates for different scenarios. The section defines values that are returned after the stack creation. These outputs provide access to important information about your deployed resources, such as resource identifiers, IP addresses, or DNS names. Section 3. Delving into CloudFormation. Stack operations. CloudFormation stacks represent a collection of AWS resources managed as a single unit. Stack operations are the actions you perform on these stacks, such as creating, updating, or deleting them. Understanding these operations is crucial for effectively managing your infrastructure through CloudFormation. The operation initiates the creation of a new stack based on your CloudFormation template. CloudFormation provisions the resources defined in the template, configuring them according to the specified properties and dependencies. During stack creation, CloudFormation monitors the progress and reports any errors or issues that may arise. The operation allows you to modify an existing stack by applying changes defined in an updated template. CloudFormation analyzes the changes and performs the necessary actions to bring your stack to the desired state. This might involve adding, modifying, or deleting resources. Change sets provide a preview of the changes before they are applied, allowing you to verify the impact of the update. The operation removes all the resources associated with a stack. CloudFormation systematically dismantles the stack, ensuring that resources are deleted in the correct order to avoid dependencies issues. Deleting a stack permanently removes all associated resources, so it's essential to exercise caution when performing this operation. Section 4. Comparing CloudFormation with Terraform. Choosing the right IAC tool. While CloudFormation is a powerful IAC tool specifically designed for AWS, other tools like Terraform offer multi-cloud capabilities. Understanding the differences between these tools can help you choose the right solution for your specific needs. CloudFormation is deeply integrated with the AWS ecosystem, providing seamless access to AWS services and resources. It leverages AWS-specific features and functionalities, making it a natural choice for managing AWS infrastructure. Terraform, on the other hand, supports multiple cloud providers, allowing you to manage infrastructure across different platforms using a consistent approach. CloudFormation uses JSON or YAML for defining templates, while Terraform uses its own HashiCorp configuration language, or HCL. While HCL is designed for infrastructure management, some developers may find JSON or YAML more familiar. The choice depends on your team's existing skills and preferences. CloudFormation's state management is handled within AWS, while Terraform requires you to manage the state file yourself. This can be an advantage for CloudFormation in terms of simplicity, but Terraform's external state management offers more flexibility and control. Ultimately, the choice between CloudFormation and Terraform depends on your specific requirements. If you're solely focused on AWS, CloudFormation provides a streamlined and integrated experience. If you need to manage infrastructure across multiple cloud providers, Terraform offers greater flexibility and portability.
Exploring the GitLab ecosystem, a comprehensive overview. GitLab is much more than just a repository management service. It's a comprehensive DevOps platform that streamlines the entire software development lifecycle. From planning and coding to testing and deployment, GitLab provides a centralized hub for managing all aspects of your projects, including your valuable infrastructure code. This integrated approach fosters collaboration, improves efficiency, and accelerates the delivery of high-quality software. At the heart of GitLab lies its powerful Git repository management system. Git, the distributed version control system, enables you to track changes to your code, collaborate with team members seamlessly, and revert to previous versions if needed. GitLab builds upon Git's foundation, providing a user-friendly web interface and a rich set of features that enhance the version control experience. Beyond version control, GitLab offers a wide range of integrated tools that support the entire DevOps lifecycle. Issue tracking allows you to manage bugs, feature requests, and other tasks related to your projects. Built-in CI/CD pipelines automate the testing and deployment of your code, ensuring rapid and reliable releases. And with features like code review and merge requests, GitLab promotes collaboration and code quality. GitLab's comprehensive nature simplifies the development process by providing a single platform for all your needs. This eliminates the need for juggling multiple tools and streamlines workflows, allowing teams to focus on delivering value to their users. Whether you're working on application code or infrastructure code, GitLab provides the tools and features you need to succeed in today's fast-paced development environment. Diving deep into GitLab repositories, version control, and collaboration. GitLab repositories are the core building blocks of your projects, providing a secure and centralized location for storing and managing your code. These repositories leverage the power of Git, the distributed version control system, to track changes, facilitate collaboration, and ensure code integrity. With GitLab repositories, you can confidently manage your code base, knowing that every change is meticulously recorded and easily accessible. GitLab's repository management system extends beyond basic version control. It offers a rich set of features that enhance collaboration and streamline workflows. Merge requests provide a structured process for reviewing and discussing code changes before they are integrated into the main branch. This fosters code quality and ensures that all changes are thoroughly vetted by the team. Branching is a fundamental concept in Git, allowing developers to work on isolated copies of the code base without affecting the main branch. GitLab simplifies branch management, providing an intuitive interface for creating, merging, and deleting branches. Protected branches ensure that critical branches, such as the main or production branch, are safeguarded from accidental modifications. Tags provide a way to mark specific points in your repository's history, such as releases or milestones. GitLab's tagging feature makes it easy to create and manage tags, allowing you to quickly access specific versions of your code. Harnessing the power of Git, the foundation of version control. Git, the distributed version control system, lies at the heart of GitLab's repository management capabilities. Understanding the core concepts of Git is essential for effectively managing your code and collaborating with your team. Git's distributed nature allows developers to work independently while maintaining a synchronized view of the code base. Commits are the fundamental units of change in Git. Each commit represents a snapshot of your code at a specific point in time. Commit messages provide a concise description of the changes introduced in each commit, facilitating code review and understanding the evolution of the code base. Branches are parallel versions of your code base, allowing developers to work on different features or bug fixes in isolation. GitLab simplifies branch management with its intuitive interface and powerful branching strategies. Merging branches integrates changes from one branch into another, combining the work of multiple developers. The concept of a remote repository is central to Git's distributed nature. A remote repository serves as a shared copy of the code base, allowing developers to synchronize their local changes and collaborate with others. GitLab provides hosted remote repositories, simplifying collaboration and ensuring code availability.
Section 4. GitLab's integrated CI/CD, automating your workflow. GitLab's integrated CI/CD pipelines are a game changer for automating your development workflow. From building and testing to deploying and monitoring, GitLab CI/CD streamlines the entire process, ensuring rapid and reliable releases. By automating repetitive tasks, you free up valuable time for developers to focus on building innovative features. CI/CD pipelines are defined using a YAML configuration file, which specifies the stages and jobs that make up the pipeline. Each stage represents a logical step in the process, such as building, testing, or deploying. Jobs within each stage define the specific actions to be performed, such as compiling code, running tests, or deploying artifacts. GitLab's CI/CD pipelines can be triggered automatically by various events, such as code pushes, merge requests, or scheduled triggers. This automation ensures that your code is continuously tested and deployed, minimizing the risk of errors and accelerating the feedback loop. GitLab CI/CD integrates seamlessly with other GitLab features, such as merge requests and issue tracking. This provides a holistic view of your development process, allowing you to track the progress of your code from development to deployment. With GitLab's integrated CI/CD, you can achieve a truly automated and efficient workflow.
Section 1. Synergizing CloudFormation and GitLab. Infrastructure. As code perfected. Imagine a world where infrastructure changes are as seamless and controlled as application code updates. This is the promise of infrastructure as code, and the combination of AWS CloudFormation and GitLab repositories brings this vision to life. By integrating these two powerful tools, you unlock a new level of automation, collaboration, and control over your infrastructure deployments. CloudFormation provides the blueprint for your infrastructure, defining the resources, configurations, and dependencies in a declarative template. GitLab serves as the collaborative hub for managing these templates, enabling version control, code reviews, and automated deployments through CI/CD pipelines. Together, they form a powerful synergy that streamlines infrastructure management and empowers teams to work more efficiently. The benefits of this integration are manifold. Automated deployments ensure that your infrastructure is provisioned consistently and reliably, reducing the risk of human error. Version control allows you to track changes to your infrastructure code, revert to previous versions if needed, and maintain a clear audit trail. Collaboration features, such as merge requests and code reviews, promote knowledge sharing and ensure that all changes are thoroughly vetted by the team. By embracing the combined power of CloudFormation and GitLab, you embark on a journey towards infrastructure as code perfection. You gain the ability to manage your infrastructure with the same rigor and control as your application code, unlocking new levels of agility, efficiency, and reliability.
Section 2. Automating infrastructure deployments with GitLab CI/CD. GitLab's continuous integration, continuous deployment pipelines are the engine that drives automated infrastructure deployments. By integrating CloudFormation templates into your GitLab CI/CD workflows, you can automate the entire deployment process, from template validation to resource provisioning. This automation eliminates manual intervention, reduces the risk of errors, and accelerates the delivery of infrastructure changes. Defining a CI/CD pipeline for CloudFormation deployments involves specifying the stages and jobs that make up the pipeline. A typical pipeline might include stages for template validation, stack creation, and stack updates. Each stage consists of one or more jobs that execute specific commands, such as validating the template syntax, deploying the stack to AWS, or updating existing resources. GitLab CI/CD offers a wide range of features that enhance the automation process. Variables allow you to customize the deployment process for different environments, such as development, staging, and production. Artifacts enable you to store and share files between pipeline stages, such as deployment packages or configuration files. And with built-in support for various deployment strategies, such as blue-green deployments or canary releases, GitLab CI/CD provides the flexibility to implement sophisticated deployment workflows. By leveraging the power of GitLab CI/CD, you transform your infrastructure deployments from manual, error-prone processes into automated, reliable workflows. This automation not only saves time and effort, but also ensures consistency and repeatability, allowing you to focus on delivering value to your users.
Section 3. Version control for CloudFormation templates, ensuring consistency and traceability. Version control is a cornerstone of infrastructure as code, and GitLab repositories provide the ideal platform for managing your CloudFormation templates. By storing your templates in a GitLab repository, you gain the ability to track changes, revert to previous versions, and maintain a clear audit trail of all modifications. This ensures consistency and traceability, enabling you to manage your infrastructure code with the same rigor as your application code. GitLab's version control features empower you to manage different versions of your CloudFormation templates, track the evolution of your infrastructure, and collaborate effectively with your team. Branches allow you to work on isolated copies of your templates, experimenting with new features or bug fixes without affecting the main branch. Merge requests provide a structured process for reviewing and discussing changes before they are integrated into the main codebase. Commit messages play a crucial role in documenting the changes made to your templates. Clear and concise, commit messages provide valuable context for future reference, enabling you to understand the rationale behind each modification. Tags allow you to mark specific points in your repository's history, such as releases or milestones, making it easy to access specific versions of your templates. By embracing GitLab's version control capabilities, you gain a comprehensive history of your infrastructure code, enabling you to understand how your infrastructure has evolved over time. This traceability is essential for debugging issues, auditing changes, and ensuring the integrity of your infrastructure.
Section 4. Streamlining collaboration and governance with GitLab. GitLab's collaborative features transform infrastructure management into a team sport. By leveraging GitLab's merge requests, issue tracking, and code review capabilities, you can streamline collaboration, improve code quality, and enforce governance policies. This fosters a culture of shared responsibility and ensures that all infrastructure changes are thoroughly vetted by the team. Merge requests provide a structured process for proposing and reviewing changes to your CloudFormation templates. Reviewers can provide feedback, suggest modifications, and ultimately approve or reject the proposed changes. This collaborative workflow ensures that all changes are carefully considered before being integrated into the main code base. Issue tracking allows you to manage bugs, feature requests, and other tasks related to your infrastructure code. By centralizing all communication and tracking progress in GitLab, you improve team visibility and ensure that nothing falls through the cracks. Code review is an essential practice for ensuring code quality and security. GitLab's code review tools make it easy to review code changes, identify potential issues, and suggest improvements. By integrating code review into your workflow, you promote knowledge sharing, improve code quality, and reduce the risk of errors. GitLab also offers features for enforcing governance policies. Protected branches prevent accidental modifications to critical branches, such as the main or production branch. Code owners ensure that specific individuals are responsible for reviewing changes to certain parts of the code base.
Section 5. Achieving continuous deployment. Infrastructure updates at your fingertips. Continuous deployment, or CD, is the pinnacle of infrastructure as code, enabling you to automatically deploy infrastructure changes as soon as they are merged into the main branch. By integrating CloudFormation with GitLab CI/CD, you can achieve true continuous deployment, ensuring that your infrastructure is always up to date with the latest code changes. With continuous deployment, every change to your CloudFormation templates triggers an automated deployment pipeline. This pipeline validates the template, provisions the necessary resources, and updates your infrastructure accordingly. This automation eliminates manual intervention, reduces the risk of errors, and accelerates the delivery of infrastructure changes. The benefits of continuous deployment extend beyond speed and efficiency. By automating the deployment process, you reduce the risk of human error and ensure that your infrastructure is always in a consistent state. This consistency improves reliability and reduces the likelihood of unexpected downtime. Continuous deployment also promotes agility. By enabling you to deploy changes quickly and easily, you can respond more rapidly to changing business needs. This agility is essential for staying competitive in today's fast-paced environment. To achieve continuous deployment, you need a robust CI/CD pipeline that automates the entire deployment process. GitLab CI/CD provides the tools and features you need to build and manage such a pipeline. By integrating CloudFormation with GitLab CI/CD, you can unlock the full potential of infrastructure as code and achieve continuous deployment of your AWS infrastructure.
Architecting modular CloudFormation templates, building blocks for reusability. In the realm of infrastructure as code, modularity is paramount. Just as you break down complex applications into smaller, manageable components, you can apply the same principle to your CloudFormation templates. By creating modular templates, you enhance reusability, simplify maintenance, and improve the overall organization of your infrastructure code. Modular CloudFormation templates act as building blocks, representing self-contained units of infrastructure. These modules can be combined and reused across different projects and environments, promoting consistency and reducing redundancy. Imagine having a pre-built module for a VPC, another for an EC2 instance, and yet another for an S3 bucket. You can then mix and match these modules to create various infrastructure configurations without rewriting the same code repeatedly. Nested stacks are a key mechanism for achieving modularity in CloudFormation. A nested stack is simply a CloudFormation stack that is created within another stack. This allows you to encapsulate a specific set of resources within a separate template, which can then be referenced and reused in multiple parent stacks. Nested stacks promote a hierarchical structure, making it easier to manage and understand complex infrastructure deployments. The benefits of modularity extend beyond reusability. By breaking down your templates into smaller, more manageable units, you simplify maintenance and troubleshooting. If a problem arises within a specific module, you can isolate and address the issue without affecting other parts of your infrastructure. This modular approach also promotes code reuse, reducing the likelihood of errors and inconsistencies. Parameterization and reusability, adapting templates to diverse environments. Parameterization is a powerful technique that elevates the reusability of your CloudFormation templates. By defining parameters, you introduce dynamic values that can be customized during stack creation. This allows you to adapt the same template to different environments, such as development, staging, and production, without modifying the core template code. Parameters act as placeholders for values that may vary depending on the deployment context. For example, you could define parameters for instance type, storage size, or database engine. During stack creation, you provide specific values for these parameters, tailoring the template to the specific requirements of the environment. Parameter types provide further control over the input values. You can specify the type of data expected for each parameter, such as string, number, or list. You can also define default values, allowed values, and constraints to ensure that the input values are valid and meet your requirements. By embracing parameterization, you transform your CloudFormation templates into flexible and adaptable blueprints. The same template can be used to deploy resources in different regions, availability zones, or even different cloud providers. This reduces code duplication, simplifies maintenance, and promotes consistency across your infrastructure deployments. Managing state with CloudFormation stacks, ensuring infrastructure integrity. CloudFormation stacks are the cornerstone of infrastructure management in AWS. A stack represents a collection of related AWS resources that are managed as a single unit. CloudFormation tracks the state of your resources within each stack, ensuring that they remain in sync with your template definitions. State management is crucial for maintaining the integrity of your infrastructure. CloudFormation monitors the state of your resources and detects any drift, which occurs when the actual state of a resource deviates from the desired state defined in your template. Drift can be caused by manual changes, external factors, or other unforeseen events. Stack policies provide a mechanism for controlling changes to your stacks. You can define policies that restrict certain actions, such as deleting a stack or modifying specific resources. This helps prevent accidental or unauthorized changes that could disrupt your infrastructure. CloudFormation also provides detailed information about the state of your stacks, including the status of each resource, any changes that have been applied, and any errors or warnings that have occurred. This information is invaluable for troubleshooting issues and understanding the current state of your infrastructure. Section 4. Stack updates and rollback strategies. Navigating change with confidence. Change is inevitable in the world of cloud infrastructure. As your applications evolve and your business needs change, you'll need to update your infrastructure to keep pace. CloudFormation provides robust mechanisms for managing stack updates, ensuring that changes are applied safely and reliably. Change sets are a powerful feature that allows you to preview the changes that will be applied to your stack before actually executing the update. A change set provides a detailed summary of the modifications, including the resources that will be added, modified, or deleted. This allows you to verify the impact of the changes and catch any potential errors before they affect your production environment. Rollback strategies provide a safety net for stack updates. If an error occurs during an update, CloudFormation can automatically roll back the stack to its previous stable state. This minimizes downtime and prevents your infrastructure from being left in an inconsistent or broken state. You can configure different rollback strategies, such as rolling back to the previous working version or rolling back to a specific point in time. CloudFormation's update capabilities also offer flexibility in how changes are applied. You can choose to update all resources in the stack at once or update them in batches. This allows you to control the impact of updates and minimize disruption to your applications.
Section 1. Branching strategies. Orchestrating code flow in GitLab repositories. Branching strategies are the backbone of effective collaboration and code management within GitLab repositories. They provide a structured approach to organizing and integrating code changes, ensuring that multiple developers can work concurrently on different features or bug fixes without stepping on each other's toes. A well-defined branching strategy promotes code quality, reduces merge conflicts, and streamlines the development process. GitLab supports a variety of branching strategies, each with its own strengths and weaknesses. One popular approach is GitFlow, a robust branching model that defines specific branches for different purposes, such as development, features, releases, and hotfixes. This structured approach provides clear guidelines for managing code changes and ensures a consistent workflow across the team. Another common strategy is feature branching, where each new feature or bug fix is developed on a separate branch. This isolation allows developers to work independently without affecting the main codebase. Once the feature is complete and tested, the branch is merged back into the main branch. Choosing the right branching strategy depends on the specific needs of your project and team. Factors to consider include team size, project complexity, and release frequency. Regardless of the chosen strategy, it's essential to establish clear guidelines and ensure that all team members understand and adhere to the established workflow. Section 2. Crafting meaningful commit messages, a guide to effective communication. Commit messages are more than just brief descriptions of code changes. They are essential communication tools that document the evolution of your project. A well-crafted commit message provides valuable context for future reference, enabling you and your team to understand the rationale behind each modification. clear, concise, and informative commit messages are crucial for effective collaboration and maintainability. Start your commit message with a short, descriptive summary of the change. This summary should be concise, typically within 50 characters, and clearly convey the purpose of the commit. Use the imperative mood for the summary, as if you're instructing the codebase to make the change. Following the summary, provide a more detailed explanation of the change. This explanation should elaborate on the reasons behind the modification, the problem being solved, and the approach taken. Use bullet points or numbered lists to break down complex changes into smaller, easier-to-understand chunks. Include relevant issue numbers or task identifiers in your commit messages. This links the commit to the specific issue or task it addresses, providing valuable traceability and context. By following these guidelines, you can transform your commit messages from cryptic notes into valuable documentation that enhances the maintainability and understandability of your project. Section 3. Versioning and tagging marking milestones in your code's journey. Versioning and tagging are essential practices for managing the evolution of your code base. They provide a structured way to mark significant points in your project's history, such as releases or milestones. Tags act as snapshots of your code at specific points in time, making it easy to access and deploy specific versions of your software. Semantic versioning is a widely adopted standard for assigning version numbers to software releases. It uses a three-part version number scheme: major, minor, and patch. The major version number is incremented for incompatible API changes. The minor version number is incremented for new features that are backward compatible, and the patch version number is incremented for bug fixes. GitLab's tagging feature allows you to create and manage tags within your repositories. Tags can be associated with specific commits, branches, or releases. Annotated tags provide additional information about the tag, such as the tagger's name, email address, and tagging date. By consistently applying versioning and tagging practices, you create a clear and organized history of your project's releases. This makes it easy to identify specific versions of your code, roll back to previous releases if needed, and track the progress of your project over time.
Section 4, CI/CD pipelines, automating the path to continuous delivery. Continuous integration and continuous delivery, or CI/CD pipelines, are, the cornerstone of modern software development. They automate the process of building, testing, and deploying your code, ensuring rapid and reliable releases. GitLab's integrated CI/CD capabilities provide a powerful platform for implementing and managing your pipelines. A CI/CD pipeline is defined using a YAML configuration file, which specifies the stages and jobs that make up the pipeline. Each stage represents a logical step in the process, such as building, testing, or deploying. Jobs within each stage define the specific actions to be performed, such as compiling code, running tests, or deploying artifacts. GitLab CI/CD offers a wealth of features that enhance the automation process. Variables allow you to customize the pipeline for different environments. Artifacts enable you to store and share files between stages. And with built-in support for various deployment strategies, GitLab CI/CD provides the flexibility to implement sophisticated deployment workflows. By embracing CI/CD pipelines, you transform your software delivery process from a manual, error-prone endeavor into an automated, reliable workflow. This automation not only saves time and effort, but also ensures consistency, quality, and speed in your releases.
Section 1. The synergy of CloudFormation and GitLab. Empowering infrastructure as code. Throughout this training module, we've explored the individual strengths of AWS CloudFormation and GitLab repositories, and more importantly, their powerful synergy when combined. CloudFormation provides the declarative language for defining your infrastructure as code, while GitLab offers the collaborative platform for managing, versioning, and automating the deployment of that code. This partnership unlocks the true potential of infrastructure as code, enabling you to manage your infrastructure with the same agility and control as your application code. Recall how CloudFormation templates, written in JSON or YAML, serve as blueprints for your AWS infrastructure. These templates define the resources you need, their configurations, and their dependencies. GitLab then steps in as the central hub for managing these templates, leveraging the power of Git for version control, collaboration, and automated workflows. This integration streamlines the entire infrastructure management lifecycle, from initial design to ongoing maintenance and updates. The benefits of this synergy are far-reaching. Automated deployments through GitLab CI/CD pipelines ensure consistency and reliability, eliminating manual errors and reducing deployment time. Version control allows you to track changes, revert to previous states, and maintain a comprehensive audit trail. Collaboration features, such as merge requests and code reviews, foster knowledge sharing and improve code quality. By combining CloudFormation's declarative power with GitLab's collaborative platform, you create a robust and efficient workflow for managing your AWS infrastructure. This synergy empowers you to embrace IAC principles, transforming how you build, deploy, and manage your cloud environments. It's not just about writing code, it's about fostering a culture of automation, collaboration, and continuous improvement.
Section 2. Embracing IAC Principles, a transformative journey for cloud management. Infrastructure as Code, or IAC, is more than just a set of tools and technologies. It's a fundamental shift in how we approach infrastructure management. It's about treating infrastructure as code, applying the same principles of software development to the management of your cloud environments. This transformative journey brings numerous benefits, including increased agility, improved reliability, and enhanced collaboration. One of the core principles of IAC is automation. By automating infrastructure deployments, you eliminate manual processes, reducing the risk of human error and freeing up valuable time for more strategic initiatives. Automation also ensures consistency and repeatability, guaranteeing that your infrastructure is deployed identically across different environments. Version control is another crucial aspect of IAC. By tracking changes to your infrastructure code, you gain a comprehensive audit trail, enabling you to understand how your infrastructure has evolved over time. Version control also allows you to revert to previous states if needed, providing a safety net for deployments. Collaboration is at the heart of IAC. By using tools like GitLab, you can foster a collaborative environment where team members can work together on infrastructure code, review changes, and share knowledge. This collaborative approach improves code quality, reduces errors, and promotes a shared understanding of the infrastructure. Section 3. The future of infrastructure management, automation, collaboration, and continuous improvement. The cloud landscape is constantly evolving, and the future of infrastructure management lies in embracing automation, collaboration, and continuous improvement. As cloud environments become more complex and dynamic, the need for automated, reliable, and collaborative infrastructure management practices becomes even more critical. Automation will continue to play a central role in infrastructure management. Tools like CloudFormation and GitLab, CI/CD will become even more sophisticated, enabling more complex and automated workflows. Artificial intelligence and machine learning will also play an increasing role, automating tasks such as resource optimization, security monitoring, and incident response. Collaboration will become even more essential as teams become more distributed and diverse. Tools like GitLab will continue to evolve, providing richer collaboration features that enable seamless communication, code sharing, and knowledge transfer. Continuous improvement is a mindset that embraces ongoing learning and adaptation. By constantly seeking ways to improve your infrastructure management practices, you can stay ahead of the curve and ensure that your cloud environments are optimized for performance, security, and cost effectiveness. This involves embracing new technologies, adopting best practices, and fostering a culture of experimentation and innovation. The future of infrastructure management is not a destination, but a journey of continuous evolution and improvement. By embracing the principles of automation, collaboration, and continuous improvement, you can navigate this journey with confidence and unlock the full potential of the cloud.